6.4 example 2, we're going to identify exponential growth and decay functions by looking at a table. So let's look at this example. Determine whether each table represents an exponential growth function, an exponential decay function, or neither. So let's start with part A. In part A, we want to look at that the x's are increasing by a constant amount. So we can see here that my x values are being added by 1, plus 1, plus 1, plus 1. So our x's are good. Now let's look at how the y's are changing. Remember, for exponential functions, they have to be multiplied by a common ratio each time. So we're looking to see what can we multiply by 270 to get to 90? What can we multiply to get from 90 to 30? And then what can we multiply to get from 30 to 10? And you can see here we're multiplying by 1/3. Just be careful, you do not want to say divide. You're always multiplying in exponential functions, so we're multiplying by 1/3. So since the numbers are being multiplied by a constant amount, this is definitely an exponential function. So now, is it growing or decaying? Look at how the y's are decreasing. They're going down over time, and this is definitely decay. Another thing to look at is if the common ratio here is between 0 and 1, then that means it's also going to be getting smaller. It's getting decaying. So let's look at example B. First, check your x's. I can see my x's here are going up by a constant amount. They're adding by 1. That's good. Let's look at our y's. Let's see if we're multiplying. 5 to 10, that's times 2. 10 to 20 times 2. 20 to 40 times 2. So again, because we are multiplying by a common ratio, this is an exponential function. Now, is it growth or decay? Well, the numbers here are getting larger as you go on, so it is exponential growth. Also, look at the growth factor that we're multiplying by. Since 2 is bigger than 1, this is going to be growth. We're going to look at example 3 here. Interpreting exponential functions. Determine whether each function represents exponential growth or exponential decay, and then identify the % rate of change. So just remember, we're using the formula from earlier. Y equals A times the quantity of 1 plus R to the T, or A times 1 minus R to the T. If we're adding to 1, then it's growth. If we're subtracting from 1, then it's decay. So let's look at part A. So in part A, the first thing that stands out to me is in this parentheses, the number is bigger than 1. So that means I must have added something to 1, and that means that we're using the formula 1 plus R, which represents exponential growth. Now, what is the R that was added to the 1? So if 1 plus R is 0.07, then R must be 0.07, which is 7%. Let's look at part B. The first thing that stands out to me is inside the parentheses here, it's less than 1. Since 0.98 is below 1, I must have been subtracting a number from 1. So that means it must be using 1 minus R, and that's the exponential decay function. So now, what is the R value? If 1 minus R is 0.98, then R must be 0.02, which represents 2%.